Hi, I'm Clark on Temptress. Today we're going to continue our series to try to find the best inexpensive lithium iron phosphate battery. Today's candidate is the Redodo 410. This is a big battery. We're going to tear it down, we're going to decide if it's a good battery, and then we're going to discuss when do you want one big battery and when do you want a few smaller batteries. As you know, I developed this thing called the BankManager. It's the reason for all these researches into good batteries. People buy that or want to buy that and then say, I need some lithium. Clark, what should I buy? I didn't have a clue. Well, I got a bigger clue now. We put it all down in the leaderboard, so go down in the description below this video and there's a link to it. It's going to tell you all the batteries we have reviewed, links to their reviews, but then data like watts per volume, watts per price, all of that kind of stuff. Anyway, it's what you need to know to make your decision. Today we're going to talk about this Redodo 410. This is a big battery. This is 10 amp hours bigger than the last biggest battery I've ever reviewed. It's a Redodo, and up till now anyway, all the Redodos have just been batteries. A lot of people put bells and whistles and Bluetooth and stuff, and Redodo seems to concentrate on just having good batteries. I've been pretty darn happy with them till now, and I hope I'm happy with this one. Well, let's start with the stats. We have a lot of battery here. It weighs 82.3 pounds. One of the lighter batteries for watts per weight. When they start getting this big, they get a challenge to move around. The 200 amp hour batteries, at 50 pounds, that's what a man can just like shove into a cupboard or something. These, you have to start being a little careful with your back. Dimensions, 20 inches. The height, and I always do the height to the tabletop here, not to the terminals, so add some space for wires and such. But we have 8.75 inches, and the width to the widest spot gives us 10.5 inches. We haven't worked out the real watt hours yet because, that's going to be on the real numbers that this battery puts out, but based on advertising, this looks like it's one of the most power dense batteries. So if space is your problem and you can physically fit this in here, this might let you get more watts on your boat. This is the price on Amazon right now as we put the video out. It's changing all the time though, and like I said, the leaderboard is going to get you a link right to Redodo, which is probably going to be your best possible price if you use the coupon. The other reason you want to go to the leaderboard is that's where you're going to find a link to buy the batteries as cheaply as possible and any discount codes that are available. It'll be right there. So, what are we going to do with this battery today? Well, I'm going to open it up. That's going to be the first step, and that's always a bit of a challenge, but we'll get into it. And of course, we will want to make ourselves safe because that could be a problem. Metal watch. We're going to charge it up. We're going to charge it up to 100%, and then I'm going to charge it beyond 100%. I'm going to find out what's going on with the BMS. At that time, we'll be inside. We can look at all the cell balances, make sure that they're the way they should be or within tolerance. Then we're going to take it back to the inverter room on Temptress. I bought some really big wires so we can hit this kind of hard and see if anything gets hot, if there's any problems. We'll put a thermal camera on it. Then I'm going to charge it up again with the BankManager to the real 100% number, no overcharge for the rest of its life again. And then we're going to run it through a discharge cycle, which will literally take days. And I'll have an accurate number of how many amp hours it can actually produce. And then we'll talk about how we like it because we'll know a lot more by then. Well, let's take a shot to getting in here. The Redodos tend to be fairly easy to open, though I guess as they get bigger, they're going to be harder. They are sealed down with silicone. A lot of the others are epoxied together, and I just have to cut the case. So I have found that if I can pry these open slowly, you know how silicone is, you just kind of work it, it comes loose. I can put silicone right back in after I clean it up, put it right back together, and it's truly as good as new. So let's see if I get lucky on this one. Well, got this open. You guys probably won't be opening your batteries, but remember, you might have to go in 10 or 5 years or something and do something. So it kind of matters. These Redodos and the Power Queen, for the most part, are put together with silicon, not epoxy. And the pedals are on the case, so that's not a problem with strength. It makes them a lot easier to get apart. Now, I'd prefer, you know, screws, but everybody's not going to be able to afford that. Anyway, I give that as a little extra plus that you can get in. So here we go. Well, let's start out with the wires. We've got 2 6s and 4 8s. I'm sure that's enough. Of course, we're going to know for sure because we're going to use the thermal camera on it and get hot. What do we have inside? Redodo says this is a 250 amp BMS, and it's labeled 250. It's Redodo's own BMS. It's your basic kind of Redodo thing. I like this company a lot. You know, if you want a Maserati, you buy a Maserati, you get Bluetooth, you get, you know, all of those bells and whistles. This is a Chevy, you know, it's a good car. It's just not super fancy, but that's what you need. And people tell me they have good customer service. I can't judge it based on how I react, you know, how they react to me, because, you know, I'm reviewing. Of course, they're going to try to butter me up, but it looks like they do what they do well. So we've got a BMS, we've got a thermal pickup on the battery. So it really is watching the battery. If the battery got hot, you know, it'll shut things down. Of course, it does the electrical thing. We're going to test that. We're going to push it hard until the BMS shuts down, make sure all that works. The BMS's job in life is to watch the cells, and cells will destroy themselves if they get wildly overcharged. Above a certain voltage, they will go pop, they'll vent gas, and you'll never get anything out of them again. They'll also destroy themselves if you discharge them right down to zero. So a BMS's job is to keep those emergency situations from happening. It's not for charging your batteries, as I say all the time. That's the bank manager's job. That's the charge regulator's job, to get long life out of the batteries. But this guy's job is to make sure that they don't die instantly, and we're going to be testing that in a bit. We have 8 big cells, and this is a 400 amp hour battery, a little more. So these are just a little more than 200 amp hours a piece, and they're in pairs. That's just fine. Nothing in here that looks scary. We're going to now hit it hard with the charging, like I said, and check for cell balance. And before I do that, so you can have a better look, I'm going to tip the battery over. These are heavy. You know, that's kind of a point. Let's talk about, why would you want a big battery? Well, you know, if you're going to buy these kind of batteries, you can buy a 100 amp hour, a 200 amp hour, a 400 amp hour. That's basically your choices. Well, if you wanted, let's say, 800 amp hours, and you did it with 100 amp hour batteries, that's too many batteries, too many interconnects, too many chances for things to get out of balance because of different resistances in the path through all the wires. And honestly, a lot of expensive jumper wires. The battery companies themselves will all agree, don't have more than 4 batteries in parallel. And that's basically the idea why. Then there's 200s and 400s for the bigger jobs. You could say, well, I want 400, so I buy 400, but you could also, of course, get 2 200s, do the same thing essentially. Which of those would be better? Well, I think if you want 400, maybe 2 200s are better. It could go either way, of course. Of course, with one BMS controlling everything, you've got this nice world where everything's going to be better in balance. But if you have 2 discrete batteries and you do have a failure, you're not totally dead in the water. You know, you still have the other battery, and you only have 2 of them, so the hookup wires are real short, and you're not going to have a big out of balance problem. So I think it's generally probably an optimal idea to have 2 of this type of battery in your system. So when you would want to buy a 410 is when you want 800 plus amp hours in your system. If you want 400 amp hours in your system, you probably want the 200. By the way, they don't sell as many of the big ones, and they sell them more at a premium price. So it's cheaper to get 2 200s than it is to get a 400. Now, all of that just goes by the wayside when reality comes into something. You know, a plan only works till the first battle. If you're on a boat and you got a bunch of little spaces, well, then you're going to have to buy a bunch of little batteries. Maybe it's not optimal, but it's not wrong. And you've got to make the batteries fit the space. Generally, you're going to use less volume with a big battery, but if it's an odd size space thing, do what you got to do. Take another look inside here, pop it open. Let me turn it around and we can use our other camera and take a look inside. So let's see what we got. I got my fluke meter, which seems to be the best calibrated thing I have. And I can reach in here awkwardly and I can get the cell voltage, cell pairs, of course. So let's just do it a little initial. Total voltage for the system is 13.58. I did charge this thing up just recently. And we reach in here. So first cells are 3.38. The next pair, 3.385. Close. The next pair, a little hard to reach, 3.433. And finally, I should have left that probe, 3.366. So this pair, even to start with, a little bit higher. So we'll probably suspect this pair will be the ones that shut everything down. And it'll be interesting to see how much higher that is. I did, in flipping the battery around off camera, pull out a couple pieces of foam. So it was a little better supported than this before, but I couldn't get access with the probe, so I took this out. I should talk about that. The case is not the case of the VoltGo. No way. But does it need to be? Probably not. I think it's adequate for most needs, particularly if you're going to stand it right side up. I certainly wouldn't mount this one upside down with all the weight on the BMS and the foam around there. And I would put it on this side down, but I wouldn't put it with this side down. And if you buy one, that would be the positive terminal flat side, probably shouldn't be down. Any other orientation looks like it would be well supported. Remember, it's the Chevy, not the Humvee. It has to be good. It doesn't have to be great because it's Chevy priced. Okay, so let's grab the charger and put some power into this. This will take a little while. I'll keep an eye on it, and as soon as this tells me that it's no longer putting power into the batteries, we'll know the BMS went out, and then I'll get right on it. I'll check that first cell first because that'll be the high one, and then I guess it's the third cell I'll check first, and then we'll fill in the blanks and see how it balances. 3.622, there it goes. Click. All right. That just shut off, and the lead cell was 3.622 I saw. They're going down, so I'm going to try to go quick with this. The next cell, this is the one that's hard to get a connection on, 3.417, 3.466, 3.44, let's say 3.45. And I'm going to go back to that first one because it drops fast, so it's actually more fair to compare this number, 3.617. These cells are higher than I would like them to be compared to the others. It's not as bad as some batteries that have come through here. The real proof of this, the pudding here, will be when I do the full discharge test and to see if we get 410 amp hours out of this. If we do, we're not that far off. And this BMS should eventually balance that out and take care of it. It's just a thing with the Chinese cells. Not the cells, with the Chinese battery manufacturers, they don't seem to be balancing the cells manually before they ship the battery. So we have a somewhat unbalanced pack, but not grossly unbalanced. This pair of batteries is a little higher than I'd like them to be. I've put out a request at the beginning of this whole series, hey guys, Chinese manufacturers, don't waste our space, make the cases smaller. I think that might be being heard because I've been seeing some offerings. We've been seeing things like this one that it just fits. So we're not getting that big wasted huge case with a small battery in it. Here's my next request. Balance your cells. Just initially balance your cells for the people getting them. I know the BMS will eventually try to adjust that, but it's a very slow process and it would look really good. I will give you a much better review if you balance your cells out to the same voltage. Do a high balance. Is that a deal breaker? No. This one's close enough. It'll take care of things. The real proof, the real thing that matters is when I do the big discharge. If we get more than 410 amp hours out of this battery, that's great. If we're going to lose just a little bit because of this misbalance, it'll shut itself off early in both directions. But, if they give us, instead of 410 amp hours worth of cells, they actually gave us 420 amp hours worth of cells, which seems to be typical. Forget what we pay for. I'm happy. Next step here is we're going to take this guy back, hook it to the inverter. I'm going to pull out as much as my inverter can do, which is about 220, 230 amps. And we're going to look at it with the FLIR camera and see if anything's getting hot, see where the heat is happening, and judge whether this is up to the high end of producing power that it's rated for. And then, of course, we're going to do the final test where we find out if it actually has the capacity. And that really is what matters. Well, we've got the battery back here where my inverter is, so we can take some big loads out of it. Unlike previous videos, my equipment just came up another notch. I now have some big double-aught wire, so I won't be inducing heat into the system. The system will be responsible for all the heat now. So no more excuses on my side, short of the fact my inverter is only 3,000 watts. So we're gonna fire this up. We're gonna burn these two heat guns hard until we get it up kind of in the 220 amp range. It's a 250 amp BMS, but I have limitations on the boat here. And let it run for 15 minutes or so, and let's see what gets hot and what doesn't. Okay, I've got the two heat guns running. I have them in different parts of the boat so that they're on different circuits, just so I'm not loading my wiring in just one spot, because this is a lot of power. And what do we have? Well, the voltage is at 12.8 volts going down. We'll see where that settles in, but that's a perfectly reasonable amount of power. And we are drawing 224 amps on my amp meter. And well, that's a goodly amount of power. We'll take a little initial look at temperature. We don't expect anything to have warmed up yet, of course. Get my little FLIR fired up. It took me about 5 minutes to get the FLIR to boot up, but it's booted up now and it's functioning. So let's take a look at what we have. So this is after about 4 or 5 minutes of running, and well, we can see some warmth in the wiring, that's for sure. Actually, we're getting 60 some degrees. That's hotter than I want it to be by far. I don't think, I'm going to say that these internal wires are up to the task. Yeah, they're getting warm. And it's only been like 5 minutes. We'll let it go, but that's warmer than it should be. 60 is not dangerous, but it only just started. Good news is the cells are fine. We can see the bus strips here, and they're just cool as can be. But the wires are warmer than I'd like to see them. Yeah, they're a little uncomfortable to the touch. Well, let's let it run a little longer and see what happens. Okay, that's 15 minutes. What did we find? Well, the wires got a lot warmer than other ones I've tested. These wires aren't probably as big as they should be for that kind of power. If you got this battery and you didn't plan on pulling more than 200 amps, I think you'd be fine. We did get up to a little over 60 Celsius, which is the verge of pain, but it's cooled down already. It's interesting to note that the heat was concentrated in this area and this area, and these, in this group, this is the shortest wire, and this is the shortest wire. So it had the least resistance, therefore it carried the most amperage, and the heat generated, for you, those of you that watch my electrical channel, I'll give you a new equation. When you take Ohm's law and the power equation and you kind of solve them to each other, you can calculate the amount of watts that are given off, and the watts equal the current squared times the resistance. So when there's a little more current, that's a lot more wattage. Anyway, I'd like to see this battery have a little bigger block wires. Next size up, I think. Is it a problem? I don't think so. It's got that nice silicone coating, so it can take some real heat. Nothing else got hot in the case. You could pull 200 amps for 2 hours, so some heat would build up. It comes down to this. If you want to really slam on the battery and use its full potential of amperage on a regular basis, I don't think this is the battery for you. There are other ones that we've tested that do better at that. On the other hand, if that's not what you're going to do, if you're going to fire it up and draw 20 amps out of it for, all night, this has no problem with that whatsoever. And honestly, that's how I use it. 20 amps is way more than the boat uses all night running our air conditioner. So this would be a fine battery to run Temptress on. I wouldn't want to try to run a welder off it or something, though. That's not really what it should be used for. Okay, now we're going to take it back. I'm going to charge it back up using the BankManager to that nice 100% where it should be stopped, not crazy high voltage. And then we're going to do a calibrated discharge, and I'll report back to you when I know how many amp hours it gave me at a reasonable rate. Well, I finished the discharge. I could discharge this at 12 amps, so it literally took, well, a lot of hours. It went on for a couple days, but I've got the numbers. The numbers aren't great. Remember when we did the full charge and we let the BMS shut off to protect the cells, we had one cell pair, number 3, that was a little bit higher than the others. Actually, it was quite a bit higher than the others. It was about 0.2 volts, I think, if I remember right. I really like to see them within 0.1 volts. And one could argue, well, they didn't balance the cells, and that'll come down over time because the BMS will do its thing. Though with such a big battery and probably the same BMS capability, it would take a while. Except I just did the discharge, and at the end of the discharge cycle, which also was ended because the BMS says one of my cells is too low, it was cell 3 again. So cell 3 was too high early, and he was too low early. That's not him being misbalanced. It's not like I can just take some power out of him, and what we do that we call top balancing, and then the bottom kind of takes care of itself. It actually isn't the same capacity as the other cells. So that cell pair in this instance, this particular instance of this battery, let's be charitable and say unlucky. Chances are you won't have this problem, but I do have this problem, and this is the battery I'm reviewing, so I'm going to talk about that problem. What did that mean in real terms? Well, it meant that when you try to charge these batteries and that one cell that has less capacity went up in voltage because, it felt like it was full from its slightly smaller capacity, you couldn't get as much power in the other cells. And then when you discharge, the opposite thing happened because, again, less capacity, so his voltage went down first, and he shut off and you couldn't get the power out of the other cells. So we didn't get as much power out of this battery as we paid for. We only got a total of 402 amp hours, and it's rated for 410, and it probably would have had that one pair of cells had just a little more capacity. So there's that. I also have another complaint about this battery. That first complaint is just this instance, and likely the other ones wouldn't have it. The other complaint is the wires. This had, if you remember, 2 6-gauge wires going to the positive and 4 8-gauge wires going to the negative. And 4 8-gauge and 2 6 are pretty much the same amount of copper. If we compare this to the VoltGo, which was also a 400 amp hour battery and also had a 250 amp maximum rating, it had 3 6s going to either side. That's a lot more copper, and it showed. If you go back to that video, you will see that when I used the infrared camera on that one, the wires didn't get terribly hot. Now they got hot at this end because at the time I had substandard wires going to the inverter and I was inducing heat. Copper carries heat. But you can see from the other side, those wires weren't making their own heat very badly. This guy isn't dangerous, but using them up there at 200 amps, the wires got up to 60 Celsius, and 60 Celsius is where things start hurting, you know, when you touch them. That's where the pain threshold kind of is. It's all silicon coated wire. It could handle more heat, but I think this battery really should have a little more copper running to its poles. Let's go through and see how it lines up on the leaderboard. So, starting with capacity, this only gets a fair. It didn't meet the capacity of what it's rated at. Usually we expect to hit that number or just a tad bit over, and this is actually under. We know why, and if you bought one of these, maybe yours would do better. I think likely it would. I don't think this is a bad company. The reason for the capacity problem was the cells, so the cells only get a fair as well because, again, my cells, they weren't great. Build quality, we'll give it a good. It could use some more copper. It's not going to probably burn the thing down, but it could definitely benefit from a little more copper in its internal wiring, keep things cooler, and have less voltage drop, so you get more of the power out of it. If you're going to use this battery at like 100 amps or lower, which is really how most people use these things, that won't even enter into it for you. The case, excellent. I really do like the Redodo cases. They're simple. It's just designed to be a battery that doesn't cost an arm and a leg, so I don't expect screws. But having it not epoxied down means I can get it there and check things, and if much later, like 10 years later, you start having some trouble, maybe you can find a guy that really knows about batteries, and with that, he can pop it open, and he can maybe balance the cells or whatever needs to be done. You'll know anyway. Otherwise, you kind of just have to throw it away, and I hate that. So I like their cases. The company is also excellent. People have been getting back to me saying they bought Redodo, they're happy with Redodo, or they had a problem with one battery, like I might with this one, and Redodo was right on it. So I gotta say their company still gets an excellent. Okay, finally, cost to value. I'm only going to give it a fair. It's quite expensive, actually. You might want to go to the leaderboard right now because there's sales on, and even though it's after Cyber Monday and Black Friday and all of that, all the companies seem to have left their new prices. I guess they're trying to roll over product before the end of the year. Anyway, bargains can be had in the lithium world right now. This one actually cost a fair amount per watt hour, and with the wiring, I don't know. I don't know that it's worth it. If you really needed to build like an 8 or a 1200 amp hour system, this is still probably a good candidate because there's a lot of battery here, and you know, it might fit and it might be the right answer for you. You don't want large numbers of batteries, as we mentioned, but it's not stellar in its cost to value. They charge a premium for their bigger case. So that's my review of the Redodo 410. Thanks for watching the review. If you like this, again, the leaderboard has links to all my other reviews, so you can go shopping around and see what I thought of batteries. I really appreciate you watching. If you would like to show YouTube that you appreciated watching, in other words, help our channel, subscribing, of course, biggest thing. Give us a like and make a comment down below. But you know, I just discovered a new thing about the algorithm. The algorithm apparently right now is benefiting videos that once you watch a video by that channel, if you watch another by that channel. So if you guys were to jump right down to the leaderboard and then watch another video by Emily and Clark, it would help this video. Thanks a lot, and bye from Clark on Tempest.